Morning, everybody. Lovely day outside today, and we're back to drakon renderer today again. It feels like I'll be working on it for the next while. I really enjoy doing it, and as you may have noticed, for the recent while, we have been focused on the layout algorithm connections, and yesterday you might have picked up that I have another idea for layout algorithm. That would be like the fourth iteration of it. I just realized that I've been adding too many special conditions to how icons are being positioned, and I'm not really a big fan of that. It makes the management of such software really difficult in the long run, and ultimately, I see this project being maintained not only by myself but also other people. I made a little bit of progress yesterday on how I want the new algorithm to be implemented. Let me show you what it is. I want to extract the first available path on the going from the left to the right, and then find further available paths starting from already positioned icons. The scanning should be starting from the bottom of the positioned icons list. But let's not talk in abstract terms. I want to show you some code. So the issue that illustrates the layout I want to work on very well is here. This is the this is the diagram I'm working on now in order to implement the new layout algorithm. So the way I want to implement this is take the first available path on the left and then scan the positioned icons from the bottom, find the first positioned icons which contains dependents that are not already positioned, and treat that as the new head of the subtree, render the subtree, and continue with the algorithm, progressing upwards. What I mean by upwards is up the list of positioned icons. Now, let's dive into the details if this is too abstract, and I wouldn't blame you if it is. So this is the first sweep of the algorithm, which is supposed to extract the first available path to the left. So this is the connection from the title icon all the way to the end icon. And what we should expect there is title, make this a little bit larger. Title, headline, icon 2, icon 3, 5 prime, 5, 5a, and end. This is what we should get here. I've done a lot of experimentation yesterday, and it turns out I was just I was just very tired, and I missed how the layout engine should be dealing with extracting the first path. The problem was in the all dependents, and specifically in the way I was using the filter function. Now it looks, oh sorry, it's in the records module. It looks something like this. So without any further ado, what I want to do today, oh, first of all, let me show you how this runs. So given the title icon, this should print all its dependents on the left, meaning it's the family of first dependent. So it's titles icon first dependent on the left, that dependence dependent on the left, if there is any, and so on and so on. So here we have the list that the algorithm returns. What we should expect. Oh, we don't have a title icon in this yet. We should correct that. Icon name 2. It has two dependents, so the next step we should expect is icon identified with name 4, and we have that. Next, icon 4 only has one dependent, which is identified by name 6. We should expect that. That has two dependents, 107. So as opposed to the error we've been dealing with yesterday, where the next icon would be 7, now the next icon is correct, and it's 100, and it's the end of the graph. So we have 1, 2, 3, 4, 5 icons plus the title icon. So that gives us 6 icons. Let's count 1, 2, 3, 4, 5, 6, 7, 8. Is this the right diagram? I think we're dealing with we're dealing with this diagram. 1, 2, 3, 4, 5, 6. 6 here. The brain should be the last one. Yeah, and then we have the end. All right. So the next step of the new positioning algorithm is, you may have noticed that the first path that I'm using here, so for now, let's just focus our attention on the new algorithm only. Okay, we managed to find the title icon. This is the existing code. And we execute this first path function to find all of its dependents to the left. So it's first dependent of first dependent of first dependent, and so on and so on. So it's the first chain of dependence. Now the algorithm returns icons, whereas I believe we can already start positioning the icons and turn this algorithm into something that returns positioned icons. So here, we just need to turn this. Oh, so D technically could be represented. So let's just first make sure that it builds. Because this is, in my opinion, a little bit more elegant. That it runs and it returns the same result. Yeah, 100 is last. Yeah, this is looking fine. Now we can start thinking of changing the return type of this function, first path, to positioned icon. And if I'm not mistaken, I used to have a function that turns an icon into a positioned icon, provided we have a parent of that icon. Let's see. I think it was to positioned icon with parent. So we have an icon and we have a positioned icon parent. But I don't believe we have just to positioned icon function. That does not take a parent, it just takes coordinates. So technically, well, the first path does not have any positioned icons to speak about. When we extract the first line of dependence, we only have icons. So we will have to rely on coordinates to use in the projection of an icon to a positioned icon. So let's just add a quick function to positioned icon somewhere here. And I'm not too worried about these old functions, we will remove them once we prove that the new algorithm is working fine. So here, we obviously need an icon. We need its x position or x coordinate. We need its y coordinate, and we return records positioned icon. And here we basically return something like this. Icon x, y. Icon. It should be fine. And now, first path instead of D takes two positioned icon. Now, just as an exercise, we will be giving this two positioned icon coordinates 13, 13. Just so that it's easy to spot and constant. Let's run it, and I'm expecting the first chain of dependence to always have these coordinates 13, 13. Lucky 13. Sorry. So you know what? I don't even have to copy it. So we have the positions always set to 13. That's great. Okay, that's good progress. Now, we need to do something with this title icon. And title icon is very easy to translate to positioned icon, because the coordinates are always going to be 0, 0. And you know what? I think this function does not belong here. It belongs in the records module. Two. Two positioned icons. Now I can remove some of the module references. Now the first paths, or sorry, the first path will be invoking this function from the module. And now the title icon. This is going to be our first complete chain of dependence. Title icon. Records to positioned icon. We know it's going to be 0, 0. And now we should see the complete path. Mm-hmm. 1, 2, 3. Okay, perfect. So we have the first path done. Now, I want to proceed. So let's commit this. So it's going to be something like tree traversal, but with a twist. It's not going to be recursive in the sense that you go to the bottom of the first branch and then return to the first branching point and do the second branch. It's going to work slightly differently. So, namely, and now that we have the first list of positioned icons, what I want to do is to scan it from the bottom to the top to find the first positioned icon, which contains dependents that are not yet positioned, if that makes any sense. But before we do that, I need to obviously fix that magic number 13 to be something more meaningful. So the first path where was I? Oh yeah, the first path will have to get the coordinates to use during the process of positioning. So we have the current icon and its coordinates x and y, which makes me really think. The reason I paused is I think what we could get away with is just to use a positioned icon as the current icon. The trick is going to be, maybe we can. The trick is going to be is that we'll have to also pass it on here. But you know what? I think we can do that. Okay, all right. Ignore me. Positioned icon. So here we have everything. All dependents. The trick is that it will have to be, this function will have to change. X. And it's in the records module. Here, so here we have positioned icon. Now parent. Get. Can we get an icon from this? We have a lot of functions that I see will melt away as soon as we remove the previous algorithm. Ultimately, the low number of lines of code is good, but not at the expense of code readability and the ease of maintenance. And I always very, very much value that. Things always go wrong, and it's super important. It's very imperative to be able to troubleshoot problems really quickly. I believe. I think we'll have to deconstruct it. Do we not have a function for this? Let's just add a function for this. Get icon. That should be a pretty simple function. So now we don't have to deconstruct. Parent. We've got it. So here, the first path method, or method, I'm sorry, it's not a method, a function. It builds, but we're still not leveraging the coordinates of the parent. So this will have to be renamed to parent because X and Y will need later. Parent. This. X. Y. The X and Y will have to change. So what we do know is that the first line will always be straight. The first line will always be straight. So the X will not change, but Y, well. So we have to subtract icon height. And now this shouldn't build because it shouldn't build because first path now accepts positioned icon, not an icon. D is still an icon if I'm not mistaken. Yep. Oh yeah, sorry, I missed the error. It's here. Yeah. Expected position icon, but it's still an icon. But it's fine. We can very easily fix it. We can say position dependent equals of course. Oops. No, title icon. Now we naturally have to translate a title icon to position a title icon. And here, instead of title icon, use position title icon. Okay. Let's run it. Let's see what happens. Okay, let's just see if this is positioned correctly. Or how about we don't check it? I have a feeling that it is. Feeling that it is. So we can do we know that the rendering is unchanged. Rendering still works, and I'm pretty happy with this. It hasn't changed in a long while. It is pretty lengthy, but it's something that we simply cannot avoid due to the nature of qualified imports, which take a lot of space, and due to the nature of me just breaking the code down like that. I think it's reasonably easy to understand, so I don't feel that we have the need to change it anytime soon, at least. So let's reuse the positioned icons term that we will also have here. Comment these three out. So effectively, we're getting rid of the product of the previous algorithm, and we say we want the positioned icons to be the position title icons and title icon dependence. We don't want to print it anymore. So we're plugging this positioned icons list into the rendering algorithm. So what I'm expecting to see is this sort of first line of rendered icons. Let's see if we do get that. And that will be in this file, real life diagram 1. And we do get that. Look at this. So let's just quickly check. We don't need that. Transport, cryopreservation, mortician, perfusion. I like this Halloween theme of this graph. Perfuse the brain. Yeah, perfect. And we have a bypass. Lovely. Remove the brain. Yes, no. Yes goes to here. We might have to figure something out for this connection. You see, it corresponds to this one. I feel we should be pushing this icon a little bit down, but I believe we will have the capacity to do so once we have the full list of positioned icons ready. And then we can just shift them around if need be. For now, I'm not worried, even if we do not move it. If we do not move it, this question would be on the level of the end icon, same row, and the connection will be a little bit funky, but still correct in terms of drakon. Okay. This was obviously prepared by hand. Therefore, a human must have left some space between this question and this action, which is fine. This is where the drakon renderer comes in. Diagrams like that, I want to be able to render programmatically. So with that, I'm pretty happy. Now, if time allows, what I would like to do today is to first commit this. Perfect. And the second thing I would like to do is to scan the positioned icons list from the bottom to the top, looking for positioned icons that contain dependents that are not yet positioned. Why I want to do that? Well, in order to draw their connections. Draw the connections eventually, but before that happens, in order to draw the subgraphs or subtrees from the bottom to the top. The bottom trees have the positioning priority, they go first, and the uppermost subtrees or subgraphs need to make room for the lower branches. So what I'm expecting to see scanning the tree from the bottom to the top, or scanning the graph from the bottom to the top, is this icon. The end does not have any dependence, so we can skip it. This icon has dependence, one of which, the end, number 100, is already present in the list of positioned icons. The other one, I believe it was 6 or 7 or 8, is not. So in the second sweep, I'm only expecting to find one icon and to put that on the graph. So this is what I believe, yeah, this is what all dependents look like. So we have 2, 3, we have 4 rendered, we have 6 rendered, we have 7 rendered, 7 depends on 100. So here, scanning from the bottom to the top, first one will be 100, no dependence. The other one, the next one will be 7. And it will find icon number 8 because 100 is already positioned. Okay, so let's try to gingerly implement that. So we get a list of positioned icons. Let's name it something irrelevant. Let's just focus on the type signature. We want the list of positioned icons. We want to scan it from the bottom to the top and return, for now, the positioned icon that contains dependents that are not yet rendered. However, as we scan the tree, we might find that there are no positioned icons which dependents are not rendered yet. So let's just use a plain, good old maybe monad. So maybe records positioned icon. And for now, let's use fold R. ACC, sorry, the ACC will be just nothing. And here we will say, if we find such positioned icon, which dependents are not yet rendered, we simply turn that nothing into just, and we ignore all subsequent positioned icons while scanning the graph bottom to the top. So here, let's call it single positioned icon. Now, we will need to implement a function called something like this. Contain, meaning positioned icons contain unpositioned dependence. This would be first to contain unpositioned dependence. So let's go to the function contain maybe contains unpositioned dependence. It will take a single positioned icon. So contains unpositioned dependence would take a positioned icon and it would return say ball. Contains unpositioned dependence. Let's call it X. If I remember correctly, records had a function that returns dependence. Something like that. So this is naturally records. Get positioned icons name of dependence. Oh, this is not the prettiest name. It's fine. So now we'll have to check if any of these names are not present in the list of positioned icons. So this function automatically now needs a list of positioned icons. All positioned icons. And in the lambda here, we would need something like this. Any single name. We could use an lm function, but we can't use lm between a string name and positioned icon. But I remember we had some lm functions here. Something like this. Do we have more lm functions? I feel we're getting pretty close. So here we will need a function. In this lambda, we'll need a function that does something like this. We have a list of positioned icons. We get a string. We return a bool. So positioned icons. So here we need any single positioned icon recurrence get position icon name single positioned icon name equals positioned icon, and here that function could be used here. see all positioned icons, single name. So technically, we could flip the arguments around, take the string first and the positioned icons next, and we can reduce the function to something like this, leaving it just partially applied. And replace this with the next. All positioned icons. Single name. Let's see if it builds. Oh, here we need to make some decisions. What to do with the accumulator. So contains unpositioned dependence. We need a case here. So case ACC off. If it's nothing, we want to run this. Contains unpositioned dependence. Then again, off. True. If it does contain unpositioned dependence, we want to return that single positioned icon. False. Nothing. Otherwise, if the accumulator is not nothing, return that. $31. Typo. $29. Oh, here we also need to pass the list of all positioned icons. Found hole. Let's call it A. Return A. I just needed a name. All right. So if we call this first to contain unpositioned dependence, and this takes positioned icon. Let's do this. Nothing. It means that we've just finished rendering. Otherwise, just pressed. Let's call it parent for the moment. Print. Oh yeah. So I'm expecting to see 8 as a result of this. Doesn't export that. Yeah, the export list is not looking very pretty, but we'll fix it. And we returned a 6. Is that right? We have returned 6. Let's see. 6. Remove brain. Remove brain. It's here. How about How about 7? Sorry. 7 is not yet rendered, is it? So in our list, you know what, let's check. Remove brain is the one we should take. Let's see the ID of it. And it's 6. Remove brain. So remove brain depends on icons 107. And 7 is the one that depends on 108. Is that really correct? Just to make sure. Let's print positioned icons. Oh, this is our last rendering. Okay, this is good. So 6 depends on 100. 100 is rendered. Now we are missing 7 rendered. So now we can say one, 2, 3, 4, 6, 100. 100. So if we scan from the bottom, 100 is something that we don't care about because it has no dependence. Going up, we have 6, which contains 100. That's already positioned. Good. But 7 isn't. Okay, perfect. So it looks like this is working. So this is good. So plan for the next session. Is something like this function. That does not take the first found independent. And just to refresh your memory, this is the first found dependent. But the first found dependent, that is not yet positioned. In that case, we will be getting 7. But that is something for another session. I feel we now need to. I think I typed something. Oh, this is not working. I think we need to commit this now. Push if we can. Oh, the key is in the container. Lovely. Anyways, oh, maybe I can. I messed something up with permissions in this repository. Of course I can't. All right. I feel we've made some really good progress today. Thanks very much for your patience and for sticking with me. Next session, we'll do that to do, and we'll render the functions. Sorry, we'll position icons recursively again. And I believe we're getting closer to a very good shape of a positioning algorithm. Very curious about how that is going to turn out. In the meantime, thanks very much.